All right, so we're jumping in 33. The log base 2 of 64 is how we say it. Now, a base means that exactly the same thing that we meant with exponents. If we said that 4 to the second power equals 16, all right, 4 is the base, 2 is the exponent, and 16 is the actual value. So what we want to find is, when we have a log, when we see log, we always need to say log is an exponent. Log is an exponent. So when you see a log, just think to yourself, okay, well, what is the exponent? That's it. All right, log is an exponent. When you're adding two logs, you're adding exponents. Okay, so when you're dividing by two logs, you are dividing exponents. That's what it all is. So a log in this case is essentially asking the question, what is the log that changes a base of 2 into the value of 64? So it's asking you, what is the exponent? Okay, because a log equals an exponent. So for a base of 2 to become 64, we're essentially asking ourselves, what exponent is going to change 2 into 64? And the answer is a positive 6. All right. Now a negative 6, an exponent of negative 6, okay, would have given me 1 over 64. Okay, an exponent that would have given me, if I would have said 2 to the 32 power, that's incredibly large. I don't even know if your calculator would do that. All right, if I said 2 to the negative 1/6, then that would be 1 over the 6th root of 2, which would be a very small number. And then this would just be the 6th root of 2. Okay, because a fraction of an exponent means, a fractional exponent means that you're taking that root. A negative exponent means you are taking the reciprocal. Okay, two things. Put that on your note card if you have a hard time remembering that. A negative exponent means a 1 over, okay, and a fractional exponent, okay, a fractional exponent would mean that you are taking the root of it. Okay, so keep that in mind. And we don't know what that root is, okay, until we see the number in the denominator. Okay, going to 34. We got the log of 343 becoming 7. What's the exponent? It's going to take that. It's going to take 343 and then actually bring it down to 7. And I don't see a 1 over 7. Okay, so right now I can cross out the negative exponents. It's not a 1 over. Okay? Now if I did 343 to the 5th power, there is no way I'm going to get 7. So forget about that. That's ridiculous. So now I've got these two choices. Now a 1 over as a log or as an exponent means that I'm taking a root. So if I took the 49th root of 343, would I get 7? Or if I took the 3rd root of 343, would I get 7? And what you have to do is just, well, 7 to the 3rd power is 343. Okay, so that means going backwards, all right, if I took the 3rd root of 343, I would get 7. Whoops, 343. So it means 343 to the 1/3 power is 7. So the answer is B. Okay, so now we're going to rewrite each equation in exponential form. Now this is the loop. Okay, I've been calling this a loop for a couple weeks now, actually a month. So what you do is you circle your base and you say 2 to this power equals this guy. 2 to this power equals this guy. Alright? 2 to this power equals that. 2 to this power equals that. Alright? So that's your answer. It's going to be B. Alright, same thing here. X to negative 9th equals Y. X to the negative 9th equals Y. So it's D. That's all there is to it. It's the loop. But see, when you see, okay, so when you see this and it says rewrite each equation, you know, look at your choices and what it's asking. Okay, it wants you to get rid of the log and convert it into an exponential form. Now here you have exponential form and you want to put it into a log. So now go the other way around. Okay, So the log, I look at my my subscript here should be the base. Now the base is the guy that's being raised to the exponent. So it looks like it's a y, okay? And the exponent is what the log always equals. So the exponent is -7/4, all right? And then what's left is the actual value, and that's x, okay? Because this guy's alone, he will be the one here. The base is here, this y, and the exponent itself is what the entire log is equal to. All right, so moving across, oh, what is that? That's yx negative d. All right, 38. Doing it again, log, the base is x. You are raising it to the y power, so we'll put the y over there. And it's going to equal 58. So x to the y power equals 58. And x to the y power, x 58 equals y, it's c. Okay. Expansion. Alright, so what I do when I see I have to use the 3 rules of logarithmic expansion and condensation. So logarithmic expansion means that everything's squeezed up into a bundle, so we need to expand it outward. Sometimes it's beneficial, sometimes it's not. All depends. It's better usually to have it like this. Nope, not necessarily. There's plenty of reasons why we would want to expand it in calculus. But let's go ahead and just actually distribute this 5 to both of these terms here, so we get 8 to the 25th and 3 to the 5th. Okay? This means I'm multiplying this fraction to itself 5 times. So in the numerator, I will have 8 being multiplied to itself 25 times and 3 multiplying to itself 5. All right. Now what this means then is, since I'm dividing, all right, then I split this up using the second quotient rule of logs, which means that I have 8 to the 25th minus the log of 3 to the 5th. Now it's just a rule. All right, and there's, if you want to investigate that further, or if you want to memorize it for the test, it's better to kind of understand that what we're doing here when you're dividing, okay, when you're dividing, it's a log, so it's exponents. And so when you have 2 exponents subtracting each other, you're actually dividing the value, okay? So the way we can do that, when we say like division is subtraction, it's such a terrible thing to say. When we say division of logs equals, we can expand it using subtraction rule, or the quotient rule. Alright, so now we can use the third rule, which said that whatever exponents are in the side of a log can actually go to the front. So we got 25 log of 8 minus 5 log of 3. And there's just nowhere else to go. It's completely expanded. So it looks like that would be A. Alright, and when we get over to here, it looks like we're not going to have subtraction, or division here. Looks like we have multiplication. So that means between these two, I'm going to split apart this log with an addition. Alright, so that is a 6. Alright, so the last rule I can use is the third rule. Okay, and then move those exponents to the front. Okay, and why? Because when you raise a log to a power, it is like it is going, it's multiplication. I'd have to dig through the papers to get those exponential. It's kind of like when you raise something to a power, that's multiplication. So that's why we can take that power and put it to the front, because it's multiplication, because that's an exponent and that's an exponent. All right. Okay, that's 40. Let's do 41, 42, and then we'll call this video. Okay. Oh no, an ln. What are we going to do? Same thing. It doesn't matter. All right, you're going to go ahead and just distribute that 6 to both of them. Okay, the ln just, it means different base, and that's totally fine. You get 8 over 12. Okay, this is just like problem number 39. I mean, it's almost exactly. And so what we do with an ln is you just preserve the ln, because when you expand it, it doesn't matter what base you have. All right. So this is subtraction, so I will get ln of 3 to the 6th minus ln 8 to the 12th. But you're going to look and you're not going to see it because what's happened is that you use the third rule to put this guy in front. And that is going to be reflected in C. Okay? So the third, this exponent can always come to the front because it's a rule. All right? Last one here. Looks like these are extremely similar. All right? That was actually an ln. I did it again. ln is not an h. So we've got 12 to the 12th and then 5 to the 3rd. All right, split it apart so that you get ln of 12 to the 12 minus the ln of 5 to the 3rd. And that exponent comes out in front. And we've got, it looks like we've got the b. Okay, b is the answer. All right, we'll stop there and move right along here.